Oh. Maybe, shall we start?
Sure. I took a Nextjournal snapshot, I believe it is, or something like that, of what progress from last time. So here's I put the link into chat. So if you are just joining, weren't here last time, and you want to see what we had typed in last time, or what I had typed in last time, you can remix that one, which is a remix of the original, or you can start with the original.
Not familiar enough with Nextjournal, but when you remix something, like if I change something, do you see it or not?
No, I think
I get a copy?
If you remix it, you now have a new copy of it.
Ah, okay.
So you can work along. We can work along in parallel. I think you can collaborate too, but I don't know that that might be a paid feature. Who knows? All right. So yeah.
No, go ahead. I'm trying to get to my remix that I had from last time and see where I stopped.
Cool.
But go ahead. So,
does anybody else? I mean, I'm okay driving again, but want to allow someone else if they would like to.
Well, I think you should, since you did the last one and we are sort of finishing that off, but next time maybe we should have somebody else do it as well.
Yeah, that'd be fun. Okay. Let me share then. All right. Can you everyone see what I'm sharing?
Yes. Should we go back a little before where we stopped just to reacquaint?
Yeah, that sounds like a good idea. So the section we stopped in was we got to the questions in parameterized queries right here, these exercises, and decided we would pick them up next time. So seeing as this is next time, maybe we can look at the parameterized queries.
Yeah.
Or maybe even just the answers to the question, this section before that. So like, here you go. Find movie titles made in 1985. So, and there's new people here, and there are people that were here last time. So, you know, please chime in. We're working on this together. So let's see. So everything's got to find and aware. And then these are all, what are these called? These called predicates, or they're constraints.
Don't know what
I forget what the title is. Unfortunately, Stephen couldn't join us tonight. He had to go at the last minute. So anyway, so M is the entity ID, or I guess it's the entity, but it also, if you get the result out, it presents itself as if it was the ID. And then you basically state all the things that you want to be true about the data you want to get back, and Datalog or Crux figures out all of the data in the database that would match that up. So this is movie year is 1985, and we bind title to what we want the result to be. So when we run it, it's booting up my closure cell. But the nice thing is Crux or live Nextjournal caches the result, so you can still browse it even though you don't have the closure running.
Do you have to run this? I mean, now that we want to go through this again, do you have to start from the beginning and click every link, or I mean, click every block?
We'll have to see. I just ran this one by itself, so we'll have to see if it got the context. Because probably at the very least we need to define the crux. Oh, there you go. Unable to resolve queue.
Yes.
Okay. So we got a brand new closure instance here. So we got to go back to the top. So we got to require crux. Which will take a little bit.
Also, since most but not all of this was really just queries, we probably don't need to click on everything, just things that are doing side effects.
Yes, definitely. Okay, that succeeded. So probably this one.
Yeah.
Okay. And start the node in-memory instance of Crux. I think it's going to be the latest one, right? Yeah, release. We're using the latest. We're using a newer version of Crux this time than we did last time. Fresh bits. Oh, okay, that worked. So then we should submit that as a transaction. And then, cool. Seems reasonably up to date. Yes.
Yep. Yep. Where were
This is just a query, but make sure.
Okay.
Oh, sorry, what? Oh, there it is.
Yeah, there. That's what I was looking for as well.
Okay, so I think that's all of them. I think the rest of it's all queries.
Yeah.
So here, back to these exercises. There we go. That looks better.
All right.
Now, none of us actually bothered to cross-check this with IMDb, but I assume this is the correct information. Okay, one thing I found, I was trying to, so here's the extension that Nextjournal made. Let me see if I can find the chat. And it has the documentation for all the structural editing and everything that you can do. And for me, the big one was tab. So if you hit tab while you're in here, it reformats it so that the the white space is there. So for people like me that care about that, that was a useful thing to find. And then control, for me, I'm on Windows, but it's control enter to run it. And then if I want to run just one thing by itself, it's alt enter. See, and if I hold down alt, it shows me what it's gonna run. I mean, that's kind of boring, but it does show what it is. So anyway, It's more than just a text box. Okay, so what year was Alien released? So this time we have the year as the variable, or the binding, and Alien as a static variable, so, or as a static string. So we get 1979, which I think is correct. And then who directed RoboCop? One thing that I found useful to kind of carry along with me in this, because I kept, when I was going back through this morning, when I was trying to like refresh my mind, I had like, I just copied and pasted like one of the people and one of the movies in, so that you kind of know what data, what columns there are, so to speak. Because it's kind of hard to know when you go from like who directed RoboCop. Well, how does that relationship even work? And so Crux just like director here, this is an ID. So James Cameron, this by that ID being there, it points to the entity of James Cameron. And whenever there's a collection, it actually like flattens it. So you can use movie cast will match each individual person by themselves, not just all three of those like that. So it kind of unrolls collections at that level, which I think is cool. Yes.
Sorry, I was just going to ask a question about that. So Crux is schemaless, right? So there's probably not like an explain. And if I needed to find this information in an application, I would need to refer to like the structural schema using spec, or what is there a way, or is that I would just have to find that, you know, explore the maps and see what's there?
Yeah, I don't know. There isn't really an explain. I don't know. Does anyone else know of one?
I don't know, but given that it's supposedly schema-less.
Yeah.
There's...
That's a fine answer. I'm just...
Yeah, I think it's the same. Like there was, I forget where I read it, but I think it might even been Rich Hickey who said that sometimes when you have data that is schemaless, you then have to rely back on your documentation. Like, and so you have to know what you put in order to know. I mean, so there's a certain amount of discipline there. There may be an API that basically says like, get me all of the entities, like get me all the maps. So you could like figure it out from a data mining point of view. But probably much easier to have good documentation. And this actually, I captured James Cameron and the Terminator because they have this in common. You know, it actually shows a relationship. But as I was scanning through the data, some of the movies have a top level key called trivia. And so this does not even represent the schema. And so I think there'd be some discipline that you have to have as a programmer.
I wonder if there's we could write a query, I mean, maybe not right now, but that would get the union of all the keys for that entity.
Oh, yeah.
I think that would assume sort of type, right? Like you have to have a type attribute.
Well,
yeah,
right.
I mean, and don't forget that for a given entity ID, the keys it has will change over time. And each individual entity ID doesn't necessarily have to have the same keys as any other entity of, quote, the same type, because they're just attributes that belong to a particular entity.
Yeah.
I wonder if we can just do like this. We basically say anything and anything, and I want to get the attribute out of it. Oh. Didn't like that one. although it's red, but there's, oh, here. Query didn't match expected structure. Did I somehow otherwise compromise this? I wonder if that middle thing has to be a keyword.
There's the trailing. Oh, never mind.
You probably have to have one of them not be a variable. It's still 3 variables.
But what are you doing? Are you selecting the whole block?
You're essentially selecting the entire database and trying to find every attribute in it.
Yeah, it's not liking that. Well, when I run it, like I hold down Alt, you can see it changes to a different color.
Yeah.
If I hit Enter, it'll just run that query. It won't run the rest of it.
I mean, if you put the last one and change it to Robocop, it would be interesting to see if you actually do get the attributes back with the value of Robocop.
And I think if I do Alt Shift, yeah, there you go. I can say just.
And the answer is no.
No.
Okay, well, this is okay. I mean, we're working with an application. We should understand the data that we've put in. This is good. I just occurred to me as you said that, Nate, right? Like when you posted this for reference, these matches.
Yeah. Yeah, no, that's a good point. Okay, let me just take this back out. Okay. So I remember last time it was kind of interesting to like look at this kind of query because it's like who directed Robocop. So you know the movie title is Robocop, and you want to find out who directed it, not just the idea of the person, but their name. And so you kind of grab onto the data at the point where you know it, and you kind of search. You basically assert relationships to the point where you are at your answer. And so this is like the movie name is the movie title is Robocop. And then movie director is director. This is just a variable we put in here. And because these two M's are the same, Crux will make sure that they're constrained. So it'll bind across those two predicates. And then director down here, director's name is name. So that's what we want out of it, is the name. And who directed Robocop. Okay. And then this one was, I think this was submitted by Sean last time. Find the directors who have directed Arnold Schwarzenegger in a movie. And so the person is Arnold Schwarzenegger. They're cast in a movie. And then that same movie has a director, and the director's the name. And like, it's really interesting. I think they like, I don't know if I said it last time or someone said like basically everything is indexed. So you can surf through any column and it matches with anything else and then go into that next one. There you go. And I know James Cameron directed him at least once. Cool. All right. Well, anything before we go through the parameterized queries again? Anybody have any questions or any observations? Cool. All right. So like we talked about last time, parameterized queries are ways of passing in, parameters to the queries instead of hard coding them in the query itself like this. So it says, would be great if we could reuse this query to find movie titles for any actor and not just for Sylvester Stallone. We do that by adding an in clause. And in is just, they take the variables out here and pop them in here as parameters, just like a function does. So it's a vector, just like a function vector. Here's the query with the input for parameter for the actor. What was this? This is, oh, movies that this actor has been in. Okay. This is a query that I added when I was going through it again today, because I wanted to get these movies in the order that they were done. And so I added the movie year here and the movie itself. So when you run this one, you can see it has the ID, the year, and so now they're done in order. So you can see that Arnold took a break and did some different movies before he came back to the Terminator. As I was going through, I found myself doing this, like basically taking the data and processing it, post-processing to get it to sort correctly. I think last time, if I remember correctly, we talked about sorting, and generally speaking, people sort after they get the data back into Clojure. They don't sort in the database. But maybe we'll find out a way of doing that in the future. So tuples are basically just a short vector and can be used when you want to destructure an input. Say you have the vector James Cameron, Arnold Schwarzenegger, and you want to use this input to find all movies where these two people collaborated. Wow, there's a lot of predicates there, or a lot of statements.
But the tuple thing is only in the in clause or anywhere else as well?
Looks like it's just like it's this destructures into this in here, inside of here. Also, this would only tell us when James Cameron was the director and Arnold Schwarzenegger was the actor. It would never tell us if Arnold was the director and James Cameron was the actor, but I guess that hasn't happened yet. Interesting. Of course, in this case, you could have just as well used two distinct inputs instead. Oh, okay. Well, so we could just here. I'm just going to copy the whole thing. We could just take this. We can figure out how to delete inside of. Okay.
how would you do that? How would you find out if two people have collaborated? I think that kind of goes back to the previous question that we had about finding attributes. But anyway, how would we find out if two people have collaborated?
Regardless if one of them was the director and the other one was the actor?
Right, regardless of role, right?
Well, yeah, you would need a way of doing, because all of these have to be true in order for it to Crux to return data. So it has to be like a nested OR, like this one. We basically need these to be duplicated where the A and the D are flipped. But if we added those clauses, nothing would match because nothing would match. It's a good question. I don't know.
Well, I mean, from what we know right now, I don't see any way other than to do it outside. So you could do, actor, director, and then director, actor.
Right. Run two queries and merge the sets.
And then
you can do an OR.
Inside the query, Sean?
Yeah, there's a clause can be a parenthesized OR of multiple tuples according to the documentation.
Okay.
I will post an example from the docs in the chat.
It looks like after parameterized queries, we come to predicates. So maybe later on today we will, or like in this, we will get. Okay, I see your example.
Okay.
Okay. It's not far off from what I thought it would have been.
Yeah, I don't know if they, nope, they don't give that example in the tutorial, in the online tutorial.
Well, good to know it's possible. I wonder why, if you could do tuples, or you can just pass them in as discrete variables.
It's going to depend on the shape of data you're getting. Maybe you get things as a vector, or maybe you get them as separate arguments.
Oh yeah, because you could also
basically just doing a destructuring.
Right, you could do it like if you were, but you might get handed a map, and you could destructure the map inside of the in if you wanted to.
Yeah.
Seems a little involved, but yeah. Yeah, I guess in a real production database or code, you're not going to have literal strings here. You're going to have some data that comes from somewhere else. So that will force you down one of the roads or the other. Cool. I would try the OR up here, but I don't think that there's any of the movies that have the reverse relationship. So I don't know that we'd get any useful data out of it. But it's worth a try later. All right, so you can use collection destructuring to implement a kind of logical OR in your query. So you want to find all the movies directed by either James Cameron or Ridley Scott. Oh, yes. Remember this from last time. With the ... there is actually, it's not something goes here. That's actually the way the syntax. So
is that sort of similar to the thing that you said right at the beginning about how the cast of a movie was a collection, right?
This is just a collection syntax that essentially says, run this for all of these things. In the last section, someone was asking about this because they said there was a ... notation in Datalog. And we couldn't figure out what it was. And I think looking ahead, it was kind of like this, which says, match director against all of the elements in the collection that's passed in.
kind of like a splat, right? Where it's splatting the
Like
values into that.
Did you say a splat?
Yeah.
Yeah,
Yeah.
isn't
Yeah.
yeah, I think that's a that's what comes to my mind too.
Yeah.
What's a splat?
It's in other languages. It's I forget which ones, but is it JavaScript that has it? Python that has it,
JavaScript.
where you
Yeah,
have
Golang.
a syntax that
Go
basically
has it
says
too, yeah.
unroll a collection, or whereas in Clojure we just use apply.
Right. Yeah, we use apply.
Right.
Yeah. So yeah, we use either apply or we use the ampersand to like collect them into a collection. Other languages have an actual construct.
So we might be able to use this in the query that we were discussing before, where the person, and use like person in place of actor and director instead of unique roles. And this operation that might.
So we could do.
So replace director actor
Oh.
in clause with a P or person. And yeah,
P.
and dot, but we want to remove the inner vector brackets. I think.
Could you explain what you're trying to achieve? I'm not following what you're suggesting here.
So
because this still has this
still
has to be the variables that you're passing in. The dot
Right.
dot just means it essentially runs the query and unions the results for each value of it from the collection.
But I think if we change direct now in the clause, in the where class, change director and actor to both to P.
That'll just give you movies where the actor and the director is the same person.
For the same for those. Okay. So
Right, because
Yeah.
we've got movie director D and movie cast A.
Yeah.
Cool. Okay, so then relations are the third or fourth, I think. Yeah, fourth. Our set of tuples are the most interesting and powerful of data input types, since you can join external relations with the triples in your database. It's a simple example. Let's consider a relationship with the tuples movie title, box office earnings. Let's use this data and the data in our database to find box office earnings for a particular director. This is just basically creating facts in data and using them as part of the query. You can mix them in. So this gets bound to title, and this gets bound to box office. So then title, right? So title binds to the movie, and these two bind the person's name, the director, to the director of the movie. And so the only movies that will come through are the movies directed by that director. And because this relationship is here, box office gets matched to that title. Well, I mean,
why isn't it like the in clause, say, with the ... notation, since there's a collection coming in as a parameter? Or maybe this is the way it is.
oh, I don't know. I mean, the director. It's interesting because this data amount of data right here, this data is right here. We're basically using the data in the database to select out of the hard coded data we have that's outside the database. And so you can match these things with that external data and use Crux to limit that external data down. Because this right here, title box office and title box office are identical. I mean, I don't think you have to have that for this kind of a thing, but I'm just noticing about this particular form. Is that you're using Crux to select out of, to match this with the movies that person's done. Note that the box office logic variable is not pure in any of the data patterns. Anybody have any questions about this?
No.
This was one that as I was playing with it this afternoon, I wanted to see, because I noticed that there was a sequel ID in some of these. I wanted to find out all the movies with sequels. And so this is not related to any of this this section. I was just playing with the data, and I thought it was interesting that you can figure that out. It feels like you're folding the data in on itself. And so like I have title and then sequel title, of course, because you have to disambiguate them. But oh, actually, as part of the Crux diary they released today or yesterday, the dev diary. I think that one of the things they mentioned in there was the possibility of using Crux for as a graph database. So I think that this is kind of getting close to that. Any questions or thoughts?
Yeah. I was just wondering if we may not have enough knowledge at this point, but instead of having something like Mad Max to Mad Max 2, Mad Max 2 to Mad Max Beyond Thunderdome, maybe return a set of all three of them.
All the movies that are tied together via sequel?
By sequel, yeah. But I don't know that.
Yeah, that is interesting. I mean, you could obviously do it with post-processing, take this data and make that what you said, but could we make Crux do the work for us?
But yeah, maybe we don't know enough at this point to do that, how to do that.
I don't know enough at this point, that's for sure. All right. So now we finally get to the exercises. Alex asked the question, is this essentially using the closure syntax to query a graph DB, or is there more to this, like creating a DB with Datalog? Well, one thing I think that we worked through last time, but we kind of glossed over this time is every time you submit a document, Crux breaks it apart into entity, attribute, value, these triples. And so when you're querying Crux, you're actually querying the triples. And Crux knows how to turn an entity ID back into the document if you ever need that. But this is why the syntax is the way it is. I mean, the similar syntax to what you use for Datalog or for Datomic or any of the other Datalog databases. And so that's why there are triples there. And so that's why you're matching the different things. So that's why that first thing is always the ID. And attribute is always in the middle. So it definitely, I would say it's more like creating and querying a database with Datalog. I think you can use it to make a graph queries, but it's not a graph database. It's a EAV database. Yeah, data. Okay, this is calling it data patterns. That's what it's calling these with the where clause. So. Let's see where we exercises. All right. Anyone can feel free to take a stab at one of these. Let me know which one you're working on, and I'll type it in. So let's see. Find movie title by year. So these are just simple parameters. Oh, good to see you, Chris. The year, right? Find refers to an unknown variable title. Oh, here you go. Movie title. Oh, this tripped me up before. Each of these is its own vector. Lots of nesting of vectors here. There you go.
In the in clause for the next one, are we going to use that collection syntax or?
Okay. Yeah, I think that because this is like iterating over a bunch of movie titles, right? So what is it? It's two brackets.
Yeah, with dot. Oh, no, I don't know if that way. Is it two brackets or just one?
The other one up here, collections, has
Oh, yeah, it's got two.
like this.
Yeah.
Okay, and what comes next?
So M movie title, movie or year. M movie. M movie or year. And then ask in a collection.
Trying to struggle with my keyboard here. Redditor. Looks good. Yeah.
Yeah.
Isn't this one we just saw in the example? Final movie titles where the actor and directors work together?
Yeah, I think so. But
so we can say where actor, let's see, Linda Hamilton, and I know they work together. So what do we have to do? We have to go from the actor and director to their respective person entities, right?
right. And then the movie.
Person name, actor, and director, person name, director. And then
M movie director, D.
Right. And then cast. Yep. A.
But even though cast is a collection, this should match.
Yeah. I'm feeling more and more the good reasoning that someone said last time that all the IDs should be UUIDs. Because if you just have a random collection of integers and your IDs are integers, you're going to have relationships where you did not look for them. Oh, Alex has to drop off. Thanks all. Interesting project. Hope to join again. Cool. Good to see you. And then we also need movie title. There we go.
So assuming that a director is part of the cast, I mean, I don't know, can you assume that? I guess you can assume that. Assuming that the director is part of the cast, could we not have the director and the actor be like are these called predicates? I don't know what they're called anymore. Constraints, I think you said, Nate.
I was reading up above, and I think they're called data patterns.
Oh, data patterns. Okay, so if you don't specify actor and director data patterns, would that give us what we want in terms of like not this particular question, but the question before, whether or not two people has collaborated on a movie?
Mm-hmm.
And if so, like, how would you distinguish like person one and person two?
Well, you can't have two variables in there being essentially unbound. So I think we've already established you can't do that.
Yeah.
I see.
Well, and the data, like I just pulled up the Terminator data, and the director is not a member of the cast, so we would have to modify our data to try that out. But we could look at, so Linda Hamilton and Arnold Schwarzenegger were both in the cast of the Terminator. So we could try to search for all the times they worked together, as in they were both cast members.
Yeah, so you could have actor 1 and actor 2, and then,
so
you know, A1 person name actor 1 and A2 person name actor 2,
right.
and then movie cast A1 and also movie cast A2. So you double up the movie cast, take out the movie director.
Okay, right, that makes sense. So our problem here is that directors are not part of the cast.
Well,
and
you can ask if there are any directors who were also in the cast of movies. That's a possible thing you can ask.
Right.
I see.
So you'd have to find all of the. Let's see, how would you have to tie them together? Yeah, you would have to find director where D person name director and M movie director D, and then M movie cast D. And that would tell you any movies where the director was also in the cast.
Right, because you assert both of those things to be true.
So you've kind of got to trace through the structure of the data and say, well, I know this fact. How do I get through to the next thing I'm looking for?
Yeah, got it. Thanks.
And here I wrote up what Sean was describing as far as actor 1, actor 2.
Right.
So of course, in our situation, it's the same 2 movies.
Yes. Yeah.
I'm not as much of a movie buff and the rest of them that I could figure out who else I could put in there, but maybe 105 and 106. I have the data off to the side here, so I can look at it without having to scroll around. So these 2 people, Richard Crenna and Sylvester Stallone, were in the Rambo movies. So you just have to bind it to different numbered variables. Cool. Any other questions before we move on?
No, that's good.
All right. Write a query that, given an actor name and a relation with a movie title rating, finds the movie titles and corresponding rating for which that actor was a cast member. So I went down and looked at, I didn't look at the solution, but I did grab the relation because this is kind of hard to just come up with off the top of your head. So I do know this goes in here. So an actor name and a relation. So we need an actor name. We need, oops. Let's go with our, okay.
Nate,
so what do we need here? Yes.
As I'm editing, the structural editing isn't letting me like delete closing stuff without using like slurping and barfing. I was wondering how you were doing that.
I am highlighting it and pressing the delete key.
Oh, okay. All right.
Because
thank you.
yeah, I have my Vim bindings muscle memory is too strong. I'm so close to using that every instant here. But yeah, I just highlight it and delete it.
Okay, thank you.
Okay. So what is the relation?
Well, you have the actor first, right?
Yeah, so you have actor, and then what did you put here?
Title and rating. I think it's in 2 brackets.
Oh, it's in 2?
I think.
Right, because this is doubly nested. Okay.
So actor, person name. Oh yeah, person name, actor, sorry.
And then who's next? The movie?
Yeah.
Movie title.
Right, and then the actor in the cast of that movie.
Cast. A.
Yeah.
Is that it?
I think so.
And we get the title and the rating out. Yeah. Okay. Oops. I accidentally took out the I in title. Cool. There you go. There you go. Oh, Mel Gibson. How'd he do? A lot more movies. Not too bad. All right. Now that we've done the exercises from the end of the last meetup, I guess we're ready to move into predicates. All right, so far we've only been dealing with data patterns. We have not yet seen a proper way of handling questions like find all movies released before 1984. This is where predicate clauses come into play. Oh, cool. Interesting. Feels a bit magic. Like, obviously less than doesn't do a whole lot. It's a pure function, but like you could put a function there that did a whole bunch of other work. And then I'm like, what thread pool is that called on? And you know, all that stuff. But it is cool to be able to just put like what looks like literal closure syntax in there. The last clause is a predicate clause. The predicate clause filters the result set to only include results for which the predicate returns a truthy value. You can use any closure function as a predicate function. Closure functions must be fully namespace qualified, so you have to define your own predicate. Awesome, you must write it as my namespace / awesome. All closure core functions may be used as predicates without namespace qualification. Oh, Sean, Sean, all the movies where the director was also in the cast. That's cool. Here, I'll just put it here at the end of this one.
I couldn't let it lie. After the question had been asked, I'm like, oh, damn it, I've got to make this work.
Yeah, thanks, John. That was me. That's great. Thanks so much.
That's cool. Oh. I didn't know if that was true of our data set, but it is. That's cool. Okay. Oh, wow, look at that. That's the whole section. Now to exercises. Find the movies older than a certain year. Find actors older than Danny Glover. Oh, wow. Oh, every person has a person/born attribute. And then the last one is find movies newer than the year that has a rating higher than the one supplied. All right, I think I'm gonna start working on the third one. Let me get that. Where was there's the data. Newer than year, so on the year, 1984. And higher than the, okay, higher than 3. Year. And greater than. I think that'll work. Anyone else following along? Critique?
You got a year as well, right? And there's a predicate for the year as well.
Oh, I didn't have a newer than year. Okay, so I got no one. Year. Oh, like this can't be, this is like a movie year. If I don't know if my math is correct. If here, let's do title. Or
Movie year.
there you go. Let's see, 1990 and greater than 6. Oh. Should have caught at least one movie. I thought at least. Interesting.
It says inclusive for the year. So maybe like equals to.
All right, that seemed to work. Although that's interesting that I passed a 6 in there. I don't know what happened here. There we go. Yeah, empty set when I passed a 6.
Probably because they're different data types. So an integer
So a long
and a
versus a
float don't
float.
compare.
They compare in regular closure though, right?
I would have expected.
Wow, huh?
Yeah,
Is 6 greater than 3.0?
the answer is no. You're asking if 6 is less than 3.0 there.
Right, sorry, but false. It does work.
They do compare, but I wonder if that's why it doesn't work in Crux.
Yeah. Yeah, I mean, that makes sense.
Huh, interesting.
We found a rock. We found something to turn over and interesting bits underneath it. So I would assume that, I mean, it would be like me going like, 1990. That also would fail, I would assume. Yeah. Fail to let me, there we go. Delete the quote. Oh, right. We had 2 more. Anyone have answers for these 2?
Could figure it out.
Yeah, I did the Danny Glover. Do you want me to paste it?
Yeah, I want you to paste it. Oh.
Yeah. It's hard. I hard coded Danny Glover in there, parameterize that, right, to make it more dynamic, but I just hard coded Danny Glover.
Wow.
Turns out that Alan Rickman is just a few months older than Danny Glover.
Yeah.
Oh.
That's cool. I when I first looked at this, I was like, I thought we would have to somehow have the actual age of Danny Glover, but we don't. You just match it out of the data that's already in there. That's cool.
What is the second date for the? Why are there 2 dates for each person?
One is the age and the other one is Danny Glover's age.
Yeah, that's me debugging because I did the same thing that Nate did. I put a greater than rather than a less than because it's on the year, not the age, right? I called it age incorrectly there. It should be like birth year.
Date of birth.
So I put those in the output just so that I could see what was going on.
I see. Okay.
Danny Glover, age. Cool. That's really cool. Feels very like clay in your hands. I feel like there's a SQL feels like, yeah, the data's over there, but this one feels like you can really reformat the way you want it to be.
Yeah, it's really nice because you can just start, like Sean said, you start with what you know, right? So you start putting in these constraints on what you have, and then you can start like piecing it together.
Yeah, definitely.
Really nice.
It's very cool.
I wonder if there's a, I mean, I would know if we know enough to write a query for all the movies that had more than 2 people in, or more than 3 people, let's say, in the cast.
Oh, interesting. Because Crux flattens that, right? It makes separate relationships.
Yeah, I'm kind of wondering, can we just say count? I don't know, can we?
Well, let's try. I'll make a thing up here.
I've been waiting to get to the aggregate functions. So I see
maybe.
that there on the side, there is like a aggregate section. So maybe it's in there.
Yeah, that could be.
So we'll wait till that. We'll wait for later. Or do you want to try it?
I think we can try one thing, and if it doesn't work,
Yeah, let's try it.
Yeah, let's just try it. So find title, right?
Yeah.
And where oh, that one more. And then you're saying like greater than 2 count. Oh, I guess. Like M. Maybe.
Yeah, that's the best we can probably do right now.
Crux is angry at us. Persistent list cannot be cast to number. Is it saying that cast is a persistent list? Huh.
But why is it trying to cast it to a number?
Does the less than try to cast it to a number? Like
Maybe
if we go
looking at the underlying ID into the ID or something.
well, no, it's not. It's not a persistent. It's yeah, that's an interesting error.
I cheated and looked ahead. So you can.
Is there hope in our future?
Maybe.
Sorry.
I don't know. You can count the number of titles in the find clause. Or so you would have to guess count the cast somehow.
Do you have like in here put the count?
Yeah, like that's the example being shown.
Interesting.
It's kind of
maybe
reminds me of a SQL. Like
oh, I see what you mean.
Yeah.
How you do it in the what you're getting back?
In select, yeah.
That's down in aggregates, right?
Yeah, that's in aggregates.
All right. Well, we'll come back to that then.
Yeah.
I like that. Show less. Okay. And then the last one is find movies older than a certain year. Okay. Older than 1985. So this is pretty straightforward now, right? We're all Crux pros by this point.
That's right.
Watch me mess it up. Movie year. Movie title.
I don't think movie year, movie year Y maybe. And then, yeah, okay.
We'll get verbose here. Oops. Inclusive cert year. Older than, less than or equal to. Or did I flip that around the wrong way?
Mm-hmm. Well, that's,
yeah,
that's fine.
Okay, I know at least Mad Max was older. Oh.
Well, it says movie year is older, so maybe we want to have less than.
We do want the other one, yeah. There you go. Oh. All right, 7:30. Should we open up a new section or should we say we're going to do part 3?
I think you can go one. Oh, 1 second.
Okay, cool.
I read ahead of this. This transformation function would have helped me avoid my error, right? We did the same thing with the year. So this shows a function how we can create an age function to calculate age from the year.
What was that again, Tyson? I missed that.
Well, we can, I mean, if we just want to read the description quickly, but this shows how to create an age function so that we can take an existing attribute and make a new attribute, right? Instead of using the movie year or a person born, we can create a function to create age attribute.
Wow. This is okay. So we make an age function and you calculate the approximate age of that person. I like that. Basically, it's like the it's just doing millisecond math, right?
Mm-hmm.
With this function, we can now calculate the age of the person inside the query itself. Oh, interesting. So you have an actual, so you can take data from the parameters and data from the database and pass them both to a function that can calculate something new. That's very cool.
Yeah, in this case of age, it gives us a more comfortable query, right? Like it would help avoid the problem that I had with like the date math, but it's be really useful to generate new information, right? That record.
Well, and this is, I mean, this function is pure, but today is, you know, that changes, like the birthday, someone's birthday is never going to change in the database. I mean, well, of course it could, you know, if it's wrong, we need to correct it, but like, it's being able to take this side effect out here and basically make this thing in here pure.
I'm not sure I understand the call there. Well, I would assume that there would need to be an entity attribute value on the transformation function call, but I guess I don't understand this form.
I think it's just creating a binding for age. That's the way I look at it.
So it's just a pure binding. Okay.
Yeah, and it's a little weird that the binding on the right-hand side rather than the left-hand side, but I guess not.
Right, like a let block.
Yeah.
So I guess I wonder if age returns multiple things, if age returned like two different things, if you could destructure it here, you know.
It seems like you can just scroll down a bit and what it's saying.
Oh, tuple.
But it's destructuring, but only like a scalar tuple collection or relation.
Transformation function has the shape blah to result binding. Result binding can be the same binding forms we saw in the in. Okay, so you do a tuple. Oh, here's how you can basically, you know, explode into a bunch of, because this is like an OR, where you can make a new relation built into your query. Wow. One thing to be aware of is that the transformation functions can't be nested. For example, you can't write two function calls. Instead, you must bind intermediate results to temporary logic variables. So it looks a little like closure, but it's not really. I mean, it is closure, but it's not like you can't just put anything arbitrarily in there.
Yeah, I was thinking you can't put a map, for example.
Yeah. Find people by age. Use the function user/age to find. Oh, did I evaluate that? Oh yeah, I did, because then I got that. Given a person and a date representing today. Oh man, find people younger than Bruce Willis and their ages. I'll let Tyson handle that one again. Find people by age. Use the function to find the age given a birthday. Okay, so find people who is this person? Tina Turner's in this data set?
Max Thunderdome.
81.
Ah.
Classic.
I guess I gotta go rewatch that movie. Okay. To find the age given a birth date. We'll find people of age. So find people who are 81. Their age and what today is. Okay. We don't need that. And then we need, what's that? User age born today. Age.
I mean, a person born.
Person born, yes.
But we probably want to say P person name, but okay, either way.
What was that again?
That's fine. Just
User age born today. User age born today is person age. And then
and a predicate, perhaps.
equal age, person age.
Yeah.
Yeah. The answer is so we probably here, how about if we go like this, person age, and we take that out. Trying to find where there's more than one. 75.
74.
74. Okay. So we did this. 74. There you go. Oh, wow. The Terminator is 74. Now, the next thing I want to run is like group by on, to find all the ages and how many actors are that age, but I figure aggregates is coming, so. All right, Tyson. Are you ready?
For aggregates?
No, I was going to say, did you do the younger than Bruce Willis?
Oh, no.
Oh, sorry.
No, I did. Is that, yeah, sorry, I didn't get that one.
No, it's okay. Should we try to figure this one out, or should we do aggregates? Move on.
Let's move
Want
on.
to do this one?
Yeah.
I'm sorry, was that move on?
No, I was thinking we should do
Yeah.
this, but
Oh,
sure,
do it?
way,
Okay.
I'm fine with either way.
Okay, let's do the homework. Let's do our broccoli. Find people younger than Bruce Willis and their ages.
We need to
So
put it in.
I'm sorry, I'm a little stuck
today's.
on that thing that you just highlighted.
The date?
Because I'm assuming that gives today's date, but my Java interop is horrible. And I don't understand how that's like, why don't you need to call like a now method or something to get today's date?
That when you construct a date without any additional parameters, it gives you now. That's essentially now.
Yeah, so I assume it does, but I thought, well, I don't know the Java util dates library at all. So I assume there's like a method call that you can get like today's timestamp.
The constructor is that. When you
So the
construct
constructor
a date,
is just,
yeah, when you construct a date, it is today's date.
oh, okay. So that's just how it behaves.
Yeah, it's an old style class with all the Java time stuff that came in Java 8. There's a now static method on all of the classes. So you'll have like java.time.instant/now or java.time.localDateTime/now.
I see. Okay.
But date is old school, and you just construct a date object and it has the time, the current date and time. I think you can construct it from a long, which is milliseconds since the epoch. So if you gave it some large integer in there, it would give you some time near 1970 or something.
So this is
There you go.
idiomatic. This is idiomatic closure, like to get today's.
Yeah, it tends to be a pretty good shortcut because a lot of code assumes it can still work with the old style date rather than Java time.
Got it. Okay, thank you.
Java time was a Java 8 thing, right?
That's right. Yeah.
Yeah.
And it was done to essentially bring in what had been Joda time, that was a library developed outside. And I think it was like JSR 319 or something. And the guy who designed and developed Joda time went on to design Java time. And he said that Java time corrects several of the problems with Joda time. And I only know this because I'm one of the maintainers of the CLJ time library, which we've deprecated because it's based on Joda time. And if you're using Java 8, you really should be using Java time instead. And so we've been trying to stop people using CLJ time. And that's kind of how I unfortunately have to know so much about it.
Cool. Okay. Younger than Bruce Willis and their ages.
So yeah, let's get Bruce Willis's age first.
Let's get Bruce Willis's age. Bruce Willis's.
Let's find Bruce Willis the person.
Person name is Bruce Willis. Wow, you try to type a quote inside of a quote and it. Okay. And his age. Let's just do this. What is it? Age?
Born.
Was born. And then we want other people's ages.
Well, yeah, you could also do the user age and get his age. So Bruce age, sorry, open paren user age, Bruce born today.
Bruce born today.
And then Bruce
age.
Yeah.
This is the Bruce age. Yes.
Yeah. And
and now we want to do other people's ages. Person born. User age. Born today is age. And then the last thing is the predicate, right?
Yeah, we'll need the predicate and we'll need to get the person's name.
Oh, right. Yeah. We go all the way around the horn. Let's try it. Younger than Bruce Willis.
Yeah, that looks right. Edward Furlong's in there.
I do. Yeah. Graded less. They're equal. We should get Bruce Willis in here. Yep. There you go. 66. All the rest of the people are younger than 66. Yep, that's true. That's what? 7 clauses in there. That's pretty. Wonder what record it is for the most number of clauses in production code. Oh, it looks like their answer just used they just compared the borns to each other. there's a certain symmetry to comparing calculated values. I kind of like it. Cool. Any questions on the transformation functions?
Maybe I don't know. I can't. I'm trying to see if we can come up with a function that would return a tuple or some. Right now we're only returning a scalar.
Yeah.
Anyway, but maybe not.
I was wondering if there's a like, could we return like first and last name and find out everyone who has the same name or something like that, same first name. But I'm scanning the list and not finding a whole lot of commonality there.
Yeah.
Yeah, it's good. That's a good point. There's no, like, we can't really test out those other ones. Those are the binding forms. All right. Time check one more time. Should we wrap it up?
Yeah.
Do aggregates and rules next time. Maybe do a tour of the planets.
Is that the last thing? Oh, aggregates.
Looks
and
like
rules.
there's aggregates and rules are left. Yeah.
Okay.
Well, they're pretty short. Oh, rules is longer.
Hmm.
A lot longer. Oh, maybe let's do aggregates. I'm up for it. You guys up for it?
Yeah.
A little bit more.
Mhm.
Okay. Oh, look, there you go, Jay.
Yeah, you don't have to point out that I cheated.
No, you were helping us by looking into the future. We're all on the same side. We're all on the same team. Aggregate functions such as sum, max, etc., are readily available in Crux's Datalog implementation. They are written in the find clause in your query. Okay, aggregate function collects values from multiple triples and returns a single value or a collection of values.
What?
Min n.
So the minimum n elements of the set.
Interesting. Sample. Is that just like a random sample?
Random sample, I would guess. Yeah.
A random sample.
Yeah.
Well, there's no code blocks here. Count the number of movies in the database. Oh. Find the birth date of the oldest person in the database. Given a collection of actors and now familiar ratings data, find the average rating for each actor. Query should return the actor name and the average rating. Let me add some code blocks here. Find the number of movies in the database. So we don't need an in. Just M movie title. Count title.
Do we?
Oh, sorry. This needs to be in a. There you go. Sounds about right.
We should do Dorab's question.
What was that?
I feel like we should do Dorab's question about like, what was your question again? I can't remember. It was
Find all the
cast.
movies which have got more than some number of members in the cast.
Right.
Okay.
Sure.
How would we do that then?
Yeah.
Let me just make another block up here. So the question is, movies with more than. So we want to look for the movie title. Okay, that's the hard part. What's the easy part?
I'm still not sure we have enough information to do this. But let's try it.
Yeah, right. So we can get the cast, right? And then we can sum or count the cast once we get that. So
Why don't we just try a simpler query where we put the title and the number of members in the cast.
Okay, as a first way of getting there. And then we once we have that, then it's a predicate away. So then how do we find, so we go cast. So we just use it. Oh, yeah.
I'm wondering if we say instead of cast count, we say count open paren cast.
Yeah.
Or,
Right.
Sure.
And then
here do
we do M. Yeah. Yeah. Okay. Yeah.
movie.
Get 20. Yeah.
That looks pretty good.
Okay, and now we can use the result of this query, which is that a relation that we can use now in an in clause in a subsequent query?
Yeah, in
another bracket you need. Another set of brackets.
In here?
Yeah. And then a title and no, sorry, I'm not being clear. I think the query that we had should be an input parameter, like that table that you had for ratings.
Oh, I see what you mean.
Yeah.
Or what's the question again? What's the query you're trying to find? Movies.
All the movies that have more than n number of people in the cast.
Right. So like I would think we could just pass in, number needed and then have a predicate.
We could also do this outside the query and just run a predicate over the result set. Now that
but what I'm trying to get at, Nate, is that I don't think this will work if you try it, because the count can only be in the find.
Oh, that's the bind that we're in.
Right. So I think what we have to try and do, I don't know if what I'm suggesting will work or not either, but we take the query that we had and we take the result of that and pass it as a parameter to another query.
Or we could just use a filter function. We could just use a filter as well.
I see what you're getting at.
Filter because
I see I'm getting back to it there. There we go. This is what we ran.
Yeah.
So then you take this whole thing.
Yeah.
So that's exactly how I would have done it in SQL. If this was SQL.
Yes, that's
So then here we have, oops,
in
that, I know this one needs, sorry, 1 second, let me just change this. So then here we have title cast.
numcast or whatever. Yeah, cast count.
And this is the one where we go 3, because we also have although this feels a little bit like using Crux to do what would be just a filter function. Where min count.
Count greater than min count. Oh no, we have to do. Oh, you know what? Yeah, count greater. Yeah.
Need an extra level of nesting around the condition.
Ah, yes. I keep forgetting that.
Because I'm trying this and I just made that mistake too. And the problem there is that the query returns a set.
Mm-hmm.
And I think it's requiring a vector, so you kind of need to turn the set into a vector.
Can we do an into?
Or a call to vec.
Oh, yeah, sure. That's fine too.
Wrap this in a vec. Let me go. There we go. So let me just make sure this works. Yeah, right?
Mm.
That's what we were talking about, just vectorizing that?
Yep.
And I think we need an extra level of nesting here. Just one. Here, let's change it to be great less than or equal. Get all those 3s back. Cool, that seemed to work.
Yep.
Feels like there should be a way to do it with just one query, but
Yeah, we could just use a regular.
Well, if you can use the count in something other than the find, maybe. Or another way was if you could name the thing in the find,
yeah,
the count cache, and give it a name.
right. Then you could
use that.
Yeah. Cool. Okay.
Yeah, we deserve a round of applause for that.
We answered Drop's question though. Which movies have more than 4 actors? Or more than 3 actors, at least in this data set. Terminator 2. A fine movie if I ever saw one.
What's the birth date of the oldest person in the database?
The oldest person in the database? So we want
The
person, what is it? Born.
Born.
I know we want just the min born, right?
Yeah. You need an extra set of brackets around the.
Of course I do. I'm gonna be putting extra brackets around things in my sleep tonight.
This is going to be the next movie in the sequence, The Born Aggregation.
The born aggregation, yes. Okay, so can we just go like this and say a person name name, like, is that gonna work?
I hope so. Ooh, not what I was expecting. Yeah, you just got all the people.
Yeah,
and the min didn't.
the min, because
range
it's
of
probably
min were different.
the min in the
Yeah.
scope of each person.
Yeah. Yeah, there's got to be some better way of doing this.
The name of the youngest person or oldest person. Yeah.
I mean, without nested queries.
Right. Oh, interesting. So I have an extra clause in here and it doesn't belch at me.
Well, it's not used, so it probably
Yeah,
just
it's
elide.
Yeah. All right.
Try throwing
Last one.
Inner vector in the find plots. Just to try it out,
Like wrap this in a vector?
yeah, wrap that in a vector and let's throw name in there and see if it gives us.
Name out here?
Sure, we can try that.
Or you mean inside?
Inside, yeah, if we try it inside, like we want a tuple out.
Let's just put name everywhere. The name outside didn't work.
No.
Yeah, I think it doesn't like the fact that there's a. Huh. I'm pretty sure there's a way to do that because I figured it'd be a question you want to answer. All right, last one. Given a collection of actors and the now familiar ratings data, find the average rating for each actor. Oh,
I cheated.
That should be similar.
I looked at the solution for the problem we were just looking at, and they kind of cheated because they're just asking for the birth date of the oldest person and not that person's name. So the solution shows only the min date.
The right down here, min, yeah. Well, we want to go a step further. We want to learn more. Okay, so a collection of actors. And the ratings data. The ratings data, yes, let's pull that back up again. Okay, so then here we have name and I'm just putting extra brackets in no matter what, title rating. And we want to find what? Average. Okay, I think find the average rating for each actor.
A collection of actors, so maybe you want more than one there.
Sure, let's get Mr. Schwarzenegger in there too. Okay, so we might as well get the data first, right? Movie title. And then
Yeah, movie cast.
Person name, and then M cast A.
Yep.
And then wait.
Is that enough? Oh no, sorry, the rating.
We want the rating for the movie, right?
No, but yeah, but we already have that.
Oh, we have the rating, yes.
So in the find, we just put name and average rating. I'm asking.
In the find here, we put name
And average open brand rating. No.
average.
Oh yeah, you're right. AVG, yes.
Rating.
That. All right.
With how much we just struggle with finding the name of the person that's the oldest, this seems deceptively easy. So it takes the name and all the ratings that match that name and averages them together.
I think we're having problems where in SQL we would use a halving clause. And
there we go.
We haven't yet found the equivalent of halving.
Yeah, that's true.
I seem to remember there's something called the ARDS thing from the planet tour where it behaves like having.
Yeah.
But I don't think, maybe it's not in this tutorial.
I might have missed it. Did we talk about subqueries at all?
I think we just did a subquery for Dorab's question.
Oh, okay, the count one. Because I was trying to bind the output of a subquery. Because you can have, right, the aggregates can only be in the find. But there's literally subqueries called out in the doc.
So you can do subqueries inside of the where here,
Throw it in the where, yeah.
not like we did. Okay.
Yeah. But you can't bind, I don't think you could bind the find clause of the subquery.
Sean has a solution for the name and the birth date of the oldest person. I'll paste it in here. Okay. So it finds the minimum date and then queries for that person. Huh.
It really does feel like there ought to be a nicer way to do stuff like this, doesn't it?
Yeah.
What is this fancy F first?
Oh,
Function.
just means first of first. There's F next and N first and F,
And next and
yeah. N
Oh,
next.
wow. Okay.
so it's because the query comes back like this. It comes back doubly
Right.
nested. Oh, or if
Oh,
I can
that's-
actually execute the query.
Oh, that's
Yeah,
great
that
to know. Thanks.
Yeah, just it to gets this data out of the set and the vector. Cool. So our second nested query of the night. I'm gonna think about this one a little longer. Okay, cool. All right, I think we have conquered aggregates, or we at least have understood a few things.
It turns out there are subqueries, and what you do is you put essentially what looks like the query straight into the where clause.
As in replacement of one of these, or is
yeah, you end up putting it in as a relation directly into the where clause. Let me see if I can get that to work in the where I was just doing this. Oh no, I've lost it. Aggregates.
oh, Tyson has the subqueries.
So query of that to
Oh, okay.
just quickly switch back. What was it? Bracket. Oh god, so many brackets.
Binding it as a tuple, binding it as a scalar.
We should be able to rewrite that query then. The Sean one. With the min
Yeah,
date.
I'm almost there. Almost there. I'll paste it back into chat.
Yeah,
Make it
please.
work.
I'll just
Chug. Oh,
wait a second for the right answer.
no, that didn't quite work as I expected. Query. And no, doesn't work how I expected based on the docs. What are they doing? Bind results. Ah, bind results as a tuple. Maybe that's it. Come on.
What?
Bracket. Date. Nope.
What's the
doesn't do
difference?
either.
Oh, you wrap it in more brackets.
Yeah. Yeah.
The Q in here, is this?
The function.
That's the function that I assume that's the query
that
function.
we defined? It's not the,
Yes.
or maybe it's the Crux Q function.
No, it's the
Like
no, it's not the Crux.
Ah, yeah, yeah. So it needs the double parentheses. That's what's weird about it. Okay, I'll paste it into chat. Oh gosh. And it's kind of like the double destructuring to get the first of the results.
Mm-hmm.
Oh yeah,
And
okay.
so it's that.
Okay, copying and
So
pasting
you're
it
binding it
into-
to bracket min date, which goes into the set of vectors and pulls out the first value. I mean, you're still running the query twice, but
feels more like you're doing two queries inside Crux and giving the result back instead of doing the
really
round trip
does.
twice.
It really does. I suppose.
I mean, it's all in memory, so it's not like.
And I guess Q is just the function, and it's just calling the function.
It's just weird. Do they define the Q over here in the because it like the Q function in our tutorial is like something we defined in here. So it just strikes me as weird as this Q over here would be that same function. Maybe it's
everyone
this
defines
queue
the same queue.
because it's already in there. Maybe this is what you do as a Crux developer, is you always define the same exact queue function.
I got a question here, Sean. If we look at their example, they only quoted this once.
Yeah, I just spotted that, and of course, because the whole thing is quoted, so you don't need the inner quote that I put there.
Oh, okay.
You don't need that one.
Yeah, it was just as I was trying to put the query together and get the right number of brackets.
Yeah, that's cool. I was just wondering if there was because it worked, right? I was wondering if there's maybe
Right.
with
Yeah, and it works
the
because a quoted data structure evaluates to itself.
Okay, cool.
Well, let's go the other way.
So this
Who's
does
the
feel
youngest person?
better. We think this is making 2 round trips, right? Is it like functionally equivalent to the example?
Yeah, I guess it must be making 2 queries, because it's got to run that inner query to get the data back. And this is just kind of avoiding the whole in and providing it as a parameter.
Right.
Unless somehow there's some subtle optimized magic going on, which
Well, and I wonder
unlikely
if
with the queue. But
I wonder if doing it this way makes it so that because if you did it the other way with the first here, and you're doing 2 queries, there's a chance that between this query and this query, something else inserted data in the database that would make this incorrect. But if you did it this way, where the query is nested, this one out here captures a snapshot of the database before it processes, and so this whole thing would be consistent. I'm speculating that might make it better. Am I making sense as far as the idea?
Yeah.
although the queue, I think the queue that they're talking about here is actually Crux queue.
This internal queue here, right?
Yeah, I think they're doing some magic with that and picking it up as Crux queue, and because it's a subquery, they're knowing that it's the same node. So I think they are doing something special there.
Well, is the Crux queue a macro or a function?
It's got to be, it could be either, but it could be a function because you're passing a quoted query. I don't know what it is. I'd have to.
I see. Yeah. Oh no. Okay, you're right.
Yeah.
You're right. So it could be doing something better.
Yeah.
Internally.
And so the queue that we have in this set of come on. Let's see, Crux. Def my node.
And we could specify the transaction time, right? The valid
Yeah.
to make it consistent ourselves.
Right, to lock it to a certain time.
Yeah, that's got to be some magic they're doing, because the Crux documentation has nothing to do with the queue function that we define in user space. So that's got to be a special thing that it's treated as internally in the subquery. So they're doing something internally.
Right.
Has to be.
And so I would hope that this internal query or the subquery here is run on the same
thing, yeah.
The same instance of the database, the same snapshot or whatever as the top level one is.
Yeah, I think it has to be the way they've got it described in the main documentation.
Yeah.
That is interesting.
Cool. All right. Should that be enough Crux for today?
Success.
I could keep going, but I do need to get up in the morning. Yeah.
And it's nice to do it with multiple people so we can explore a little bit more.
We can roll around in it. Yeah.
I'm glad I have so many people to help me parse through all these brackets.
Yeah, the logo for Crux should just be like 8 levels of brackets, and that's it. No critique implied. Yeah, it makes me think like I want to try to make my own data set and try to start querying, because a lot of these, like, I feel like I know these movies and actors and directors, this structure really well, but like I want to try making my own data set and of something that I use at work or something that I personal something, and try to actually use it like I would use SQL, like what's the day-to-day look like, when you're exploring the data and trying to find stuff.
Yeah, I must admit, I'm also tempted to write a little thing that sucks all of the dev data out of my MySQL database and puts it into Crux so I can play with it.
I mean, you could just do like everything out. You could probably be relatively straightforward, not doing it right now, but like taking SQL data and making, every row be a document. And
yeah, you just have to make sure all of your IDs are unique across everything.
Yeah, that's true. Most databases are all numbers, right?
Yeah, if you've got like auto increment keys, yeah. So
you have to have some translation layer. Cool. Well, thank you everyone for hanging around.
Thank you for driving.
No problem. That was fun.
Job, Nate. Thanks.
And should we do the planets one next time? I mean, I feel like Crux is, we should keep going.
So we've got some rules to finish, but
oh yeah, we do have to follow the rules.
Yeah.
I think we've gone a lot deeper in this session planets, because it basically shows that if it's the one I'm thinking, it shows like basic operations.
Oh, okay.
We've already got well past what it.
We've gone past that.
Yeah.
So
we just haven't
finish it off.
Yeah,
we just haven't gotten the planets as transactions and like match and put stuff, right?
Oh yeah, that's
so
right.
Start changing the data.
Yeah, match and excision. So yeah,
I think it'd be worth going through.
Yeah.
It deals with the bitemporality part of Crux, which is nice.
Yeah, I saw in the roadmap doc in their new development blog, they've got some really interesting stuff planned for temporal queries. Because now you can only kind of ask for certain things based on time ranges, and they've got things like go and find the time ranges where these things were true, which that's a really interesting thing. It's near the bottom.
Well, one thing I do want to point out, and a bit of self-referential, is that it mentions us, our first, the last meetup.
Well done.
Yeah, so here's the piece where they start talking about the temporal queries. So given some fact, what's the time associated with it? Which I think that's quite fascinating stuff.
Well, and temporal joins.
Yeah.
Like, when were these three facts true? I mean, this is like, yeah, you can replicate SQL. Like, you can do what MySQL can do in Crux, but then Crux is just like, oh, and then you open this door and it's like all these wonderful things that really are hard to do in SQL.
That's cool. I was noticing if you assert like two documents and say the second document loses a key, the key's just kind of gone forever from your current database. So the more temporal stuff must be needed.
Yeah, I mean, because you can say, what was in that document as of a particular time. And so
of the transaction time.
Yeah, with this one, you would actually be able to say, at what point did that key disappear?
Yeah. Honestly, all I wanted to know was like, just give me all the, even if a key's gone, give me the latest data that would have been there. So that was kind of a trick.
So
this I think is one of the things that's hard with Datomic as well. If you change the schema and you do a query on something that the key didn't exist at a
Okay.
certain time in the past and then started to exist, the documents that don't have the key won't be included unless you also say, you know, something that says, yeah, and match documents that didn't have this key or something.
Okay. Will it?
So you
will
kind of
they-
got to know what happened to your schema over time.
Right. Will Datomic give you the value if the schema hasn't changed? Like say a new transaction writes, you know, A equals 1, but just ignores B.
I can't remember with Datomic
Yeah.
whether you can. Oh, because it's not document based, it's
Yeah,
entity
exactly.
based. So you're going to update just the one column anyway. So you just update A and you wouldn't be updating B.
Exactly.
Yeah, so it's different from that point of view.
So for me, Crux was not intuitive, and I'm sort of disappointed. So I'll be following the time stuff, but that's just because of how my data behaves. So it's interesting.
Yeah.
So more self-referential stuff. I don't know if people saw we were in the Clojure DREF newsletter a couple of weeks ago about for the same video as well. I put the link in the chat. It's the July 27th. I put the link in the chat, so if you want to just click on that.
Hey.
Yeah, we're right there.
Oh yeah.
We're famous.
Infamous.
Something. One of those. Okay. All right.
All right. Thank you. I gotta head out.
Thank you, everyone.
Have a great night.
Yeah, that
Good
was
night.
fun.
Happy
Thanks, everyone.
August. We'll
Great
see you next
learning
month.
experience.
Thanks, everyone.
Thank you.
Have a good one.